Let's try to understand the life cycle of spring beans in this video. So the life cycle of a spring bean contains mainly 4 stages. The first one is the bean's creation. And in this bean creation stage, spring bean scans the application and tries to find the bean definitions for the creation. And once it finds all the bean definitions, it starts creating the bean definitions and their dependencies. And once bean definitions are created, the invoke method for these bean definitions is called. One point to note here is the bean definitions and invocation of the init method, the initialization method, are tightly coupled, which means the init method is called immediately once the bean is created. It doesn't happen that all the beans are created at once, and once all the beans are created, then the invoke method for each of these methods is called. The actual thing happens is once the bean is created, the init method of this bean is called. So here what happens is it calls the initialization method if at all it is configured. And there are 3 different ways to configure the init method. We'll see those in a while. These init methods are invoked, as I said, once the bean and its dependencies are created. Then comes the usage of the created beans in an application. And just before shutting down the application, the destroy method for these beans is called, if at all it is configured. And these are also defined in 3 different ways. We'll see that as well in a while. And as I said, these are called just before the application is shutting down. Let's see the beans creation functionality in detail here. I'm trying to make it as crisp and as simple as possible. In the actual implementation, it is pretty complicated, so I have tried to make it as simple as possible. Here during the beans creation, there are 2 main things that are happening: the beans configuration and beans initialization. In the beans configuration, there is no actual bean creation, but it configures certain things. The Spring scans the application and registers the beans. What does the registration mean here is it creates a list of string which contains the bean names, and also it stores the bean information in a map called register bean, and this map is of type string and bean definition. What is bean definition? We'll see that in a while. Also, it creates a map called register aliases, and this map contains the alias name as the key and bean name as the value. Once the bean configuration is done, bean instantiation starts. In this bean instantiation, the Spring gets the beans from the list of bean names, and for each of these beans an instance of a bean is created. Then it checks if there are any dependent beans. It creates the dependent beans as well. And once the bean creation is finished, initialization methods are invoked. Here I say initialization methods because there are a lot of methods that are being called in the initialization. Let's see each of these functionalities in detail. In this beans configuration, there are basically 3 steps. The first step is component scan is done, which means Spring scans the application and finds all the classes which are annotated with @component or @managed bean or @name, and also all the sub annotations of @component like @configuration, @services, and so on. So by default, you will find the @managed bean within the Spring application because it has the dependency of Jakarta, which contains @managed bean annotation. If at all you do not find @named, then you can inject javax.inject dependency. So once all the scanning is done for the components which are annotated, the registration of these component beans take place. And once the registration of component beans for is finished, it starts with the registration for beans which are annotated with @bean methods. Here for each of the component beans which were created in the previous step, it scans each of the component classes and checks if there is any bean method definition, and if at all there is, it registers these beans. And once all the bean scan is done, the import resource scan takes place. Import resource basically contains the XML definitions. So in this import resource process, it checks if there are any XMLs defined for this import resource annotation. And for each of these XML files defined in the import resource, it processes the bean tag, the import tag, and alias tags, and registers the bean definitions for each of the bean tags. Let's see in detail each of these steps. So before starting on those each definition steps, let's understand two main classes. There is a class called bean definition holder, and this bean definition holder has three properties like bean name, bean definition, and aliases. As the names, you can see bean name and aliases represent the information of bean name, and the aliases. The bean definition class here you see will have the information about the scope of the class, custom init method, custom destroy method, and the annotation information. And there are many other things as well which are present in this bean definition. Bean definition is an interface and it has several implementations like generic bean definition, root bean definition, and so on. We'll just consider a generic name, bean definition itself, and it contains all the information that is being read by the metadata and placed in the bean definition. In the actual implementation, it is more complicated, but we'll consider here for the simple explanation that all the information from the metadata is present in the bean definition class. In the component scan process, whenever the application is starting, the Spring checks all the classes if there is any definition of @component scan. If there is a definition of component scan, then the package names defined within these component scan annotations are added to a list of base packages. If there are no definition for @component scan, it takes the base package or the package as the package of your class in which the Spring Boot application annotation is defined. It starts iterating through these packages, check if the base package of I, these are basically the package names, and for each of the package names it checks if there is any base package. If it is there, then it gets all the classes from this base package. It not only gets the classes of the base package, it also gets the classes from the sub packages of this base package. So once the classes are retrieved, for each of these classes, it processes the class and increments and goes and checks if there is any other class, and then processes all of those classes in the base package to check if there is any class with the annotation of component, managed bean, named, and so on. So once the processing is done and there are no more classes to process in this package, it increments the I and checks for the another base package. If there are no packages remaining, it goes to the process bean functionality. Let's see what happens in the process class functionality of this component scan. In the process class implementation, the bean name is set to the class name. For each of your classes defined with the annotation component and all the stuff, it sets the bean name to the class name in the camel case if there is no name defined for that class. And then it creates an instance of bean definition using the metadata information. There is a class called metadata reader. From that metadata reader, all the metadata information is stored in the metadata object, and using this metadata object, we initialize the bean definition object. Once the bean definition object is created, an instance of bean definition holder is also created using the metadata information itself, and the properties for this bean definition holder object are set like the bean name, aliases, and the bean definition. Once the bean definition holder object is created, it is added to a list of bean definition holder, and this list is used in the next step where we are processing the classes to find if there is any definition for the @bean. And the registration of the bean takes place. In the registration of bean, the bean name is added to the list of bean names, and the bean definition information is added to the register bean map, wherein the bean name will be in the key and the bean definition is the value. Once the component scan functionality is finished, the bean method configuration starts. In this bean method configuration, it iterates through the bean definition holder list, which was created in the previous step. It checks the class if at all there is any definition for @bean. And if it is not there, then just iterate to the next bean definition holder object, which means the Spring doesn't keep any particular restriction for defining the methods with @bean annotation only in the @configuration classes. You can define the bean methods with @bean definition in any of the classes which are annotated with the component. Now coming back here, if there is no information of method definition with @bean, it iterates to the next bean definition holder. If there is definition in the bean definition holder class, it iterates through each of those bean methods, processes the bean method which is annotated with @bean. Once the processing is done, iterate through it, check if there is any other method with this annotation. If there is no other annotation, then go to the next bean definition holder and check again the same thing. Once the bean definition holder processing is completed and there are no more bean definition holders, it continues processing import resources. Let's see what processing bean method does. In the processing of bean method, what happens here is it creates an instance of bean definition using the metadata, similar to what was happening in the component scan, and then it registers the bean. In the registration of bean, it checks if there is no alias provided in the name property of the bean annotation. If there is no property, then the method name itself is given to the bean name. If aliases are provided, then the first alias is set to be the bean name and the remaining aliases are used as the aliases. And this bean name is added in the list of bean names, similar to how it was done in the component scan. And also the bean definition is added to the register map. It also adds the aliases to the map called register aliases with alias name as the key and bean name as the value. For example, if the name property for bean annotation has a list of names called A, CA and class A, the bean name here will be A and the register aliases map will have two values with key as CA and value as A and key as class A and value as A. You will see the reason why alias names are kept as key and class names are kept as value. Once the bean annotation configuration is done, the XML configuration starts. If there are any definitions with @import resource and it contains the XML file names, then all those file names are added in a list with name XML resources, and these XML resource files are iterated. So it starts with 0, check if there is any XML resource file defined. If there is, then create an object of class document. From this document class, get the node whose tag name is beans, and from these beans get all the nodes that are defined within these beans node and add them in a node list, and then initialize j to 1 for each of these node list. Process the node list of j. In a sense, these node list contains the information about tag bean, and process node list basically does the processing of those bean information. Once the processing is done, increment it, check if there is another bean or the node list information available in the node list. If there is no information, then it increments I to the next value, check for the next XML resource if at all it is defined. Once the processing of all of the XML resources is done, then bean creation process, in a sense the second step in the bean creation, gets started. Let's see what all takes place in the processing of the node list. It reads each attribute of the element bean and get the ID attribute and set the bean name with the ID attribute. Create an instance of the bean definition using the metadata information, which is read through the metadata reader, and add all that information in the bean definition, and then start registering the bean. In the registration of the bean name is added to the list of bean names, similar to how it was done in the other two ways, and then it adds the bean definition in the registered bean map. Once that is done, the aliases are added to the map. In this, the name attribute may have more than one name, so which are separated by comma or a space or a semicolon. The value in the name attribute is split using these three characters, and for each of those names after split are added in the register aliases map. Let's now see the bean instantiation or actual bean creation process. We have the informations of bean name, bean definition, and aliases in the maps and the list from whatever has taken place in the starting process. Here in the bean instantiation, it starts to read the bean names from the list of bean names. So checks if there is any bean name of I present. If it is not present, it means that all the beans are created, the process of bean creation is complete, and further steps for starting the application takes place. If there is a bean name, then the first step what happens is the resolution of the bean name takes place. Means it tries to get the actual bean name. Suppose you have the alias name as the bean name, it resolves the name from the alias to the actual bean name from the registered aliases map. You might remember the key information in the register aliases map was the alias name and the value was the bean name. If you have provided alias name in the application context.get bean method, then the resolve bean name gets the name from this alias map. If there is nothing in the alias map, then the bean name which is provided is the actual bean name. Once the resolution of the bean name is done, checks if the bean creation status is in creation, which means whether the bean is still in creation process. If it is still in creation process, which means there was a cyclic dependency caused and it throws a cyclic dependency error. If the status of the bean creation is not in creation, it checks in a map with name singleton objects. This map contains the objects created for each of these bean names, and the process checks if there is a bean already created in this map, and if it is there, it will return this object name. Remember, the whole process I'm explaining here is related to the singleton objects, and that's the reason the singleton objects.get bean name is checked here. If it is not null, in a sense the object is already created and is present in the map, it returns the bean instance of that map from this singleton objects. If it is null, which means the bean is not yet created, the status of the bean is set as in creation and a bean object is created using the information present in the bean definition, and you already know the bean definition information is present in the register bean map. So once the bean is created or the object is created, this object is added in the singleton object map, and after adding this object in the singleton object map, it checks if there is any dependency injection added to this. If there are any dependency injections, for each of those dependency injection, the call for bean creation is called again. Once all the dependencies are created, in a sense dependency injection is done, the init methods or the initialization methods are called, and once the initialization methods are called, the status of the bean is set to be created and it returns the bean instance. Here you can see, as I said, if there is any dependency injection, the bean creation for that dependency starts. Init method for the main bean will be called only after completion of the bean creation, the dependent bean creation, which means the dependent bean creation's init methods are called first and then the init method of the actual bean is called. Let's see what happens in invoke init. As I said, there are many methods which are being invoked in the init method. What it does is it gets the information from the definitions, the methods defined as init methods. Then it calls the invoke aware methods. The steps which I am explaining here are in sequence or in order, which means the invoke aware methods are called first. The invoke aware methods are the methods which have the bean name aware. Suppose your bean implements the bean name aware, you need to override a method for this bean name aware, and this bean name aware method is called. What Spring does is it checks your class. If your class is an instance of bean name aware, then the overridden method is called. Similarly, it checks if your class is an instance of bean class loader aware, and if yes, then it calls the respective overridden method, and for the bean factory aware as well. Once the invoke aware methods are invoked, the call to the method which is annotated with @postprocessor is called. And once the postprocessor method is called, the method after properties set of initializing bean is called. If your bean is implementing the initializing bean, then you need to override after properties set method. And if at all if your class is an instance of initializing bean, this method is invoked. And once this method is invoked, your custom init methods are invoked. The custom init methods here are the methods which you have defined in the configuration of @bean or the XML's bean configuration, which gives you the flexibility to specify the methods that should be invoked once the bean is created. Once the invoke methods are called, your application starts and you use those beans in your application. And just before shutting down the application, the destroy methods are invoked. And in the destroy method, similar thing happens. The first priority is for the annotated classes with pre-destroy. And once the method annotated with pre-destroy is called, it calls the destroy method of the disposable bean, which means if your class implements the disposable bean, the overridden method is called. And once this disposable bean method is called, the custom destroy methods are called, which were defined in the @bean and XML configurations. Now let's see the order of invocation of your init methods and the destroy method. Suppose your application has several beans with name bean A, B, C, D, and E, and these are created in this order which I have specified here. Then the destroy methods are called in the reverse order of their invocation of init methods. Let's see some best practices for init method and the destroy methods. As you already know, there are three ways of configuring the bean definitions. We also have the groovy thing. We are not covering those things here. We'll see the basic things. In the Java configuration methods, you can also specify @postprocessor for init method, and also you can implement your class with initializing bean for your init methods. But the best thing to do is add your init method information in the @beans init method property itself. Same thing is for the destroy method as well. If you have classes with annotation, best thing is to use @post construct and pre-destroy for initialization and destruction. In the XML configuration, the best method is to use init method property and destroy method property of the bean tag. Now let us see some practical information of these explanations. Here I have an application for Spring Boot core. This is same application which I have used in part 2 of this series of bean creations. I have a package called dive.dev, and this has the main class which is annotated with Spring Boot application, and also I have the import resource. Here the class E and class F are the annotated classes. As the package name suggests, class E is annotated with component, and I'm auto wiring the class F and the respective post construct and pre-destroy methods. Since I have this as annotation, I'm using the annotations. Same thing for class F as well, but I'm using @managed bean just for the explanation, and same post construct and pre-destroy. The beans Java configuration, class A and class B are Java configurations. You'll just see the plain class and init method and destroy methods. These init method and destroy method information is stored in the bean configuration class, which is annotated with @configuration. Here you can see @bean init A, destroy A for class A, and same thing for class B, init B and destroy B. Here you can see. Class C and class D are XML configurations. These are also the plain POJO classes you can see here. I have created the constructors just to print the information, and initialize and destroy methods are added for class C and D, and the respective information are stored in the XML. You can see here init method and the destroy method. And the bean configuration, as you have already seen the information for @bean, and also I have added the post construct and pre-destroy for this bean configuration class. Let's try to run this. Here you can see the order of creation is first class E is created because the scanning is done from here, and the order of creation is in the ascending order of the package names, and for each of these package names, and again the ascending order names in the classes. So the first comes, so that's the reason class E and class F are created. But if you see, class F's init method is called first. This is because I am injecting class F, and that's the reason the class F creation should be completed before calling the class is init method. That's the reason class F init is called, and once this is called, bean configuration is created. This is because even the bean configuration is a component. Then comes the bean definitions of Java configuration, and finally the XML configurations. The order of calls for destroy method is in the descending order. Bean D was created last, and that's the reason the first call for the destroy is for class D. And you see class F is destroyed at the last, and that's because the class F's init was called first. Now, as I said earlier, if you do not specify any @component scan for your class, it takes the package name of your Spring Boot application dive.dev, and that's the reason all these annotation classes are called, because all of these packages are the sub packages of dive.dev. Let me just change this package name and we'll see what happens here. Rename dot test. Now you can see I have changed this package name and run the application. Here you see only the XML beans are created and there is no information of creation of either annotation or Java configuration beans. This is because the default package name that the Spring has taken is dive.dev.test, and there are no component scan packages with dive.dev.test.star, and that's the reason all of these beans are not picked up and only the XML configuration is picked up because I am importing the resource here. So what I will do here is I'll just add component scan, and this component scan will have dive.dev. Start the application again. Now you can see all the beans which are annotated with the component are also created. Let me just revert these things. One more thing I have explained in the slides is the bean definitions with bean annotation can be created even if they are not in the configuration. Let's change this to component and see if these beans are getting created again. Run. You will see here class A, class B are created, which are part of this bean definition, which means it doesn't have a strict rule saying only the bean annotation can be specified under the configuration. Let me just revert it. And the final thing which I explained is you can define your more than one initialization methods in a single class. I'll just take an example of XML here, class C. In this class C, you already know these are the custom init methods defined. What I'm going to do is I'll add post construct and also implements initializing bean, and for this initializing bean I need to add the method, and this will have, let me run. You'll see let's see the class C. Here you see class C's constructor is called and then post is printing, which means post constructor is called first. Then after property set, this method is called, and finally class C init is called. And the same thing happens in the destroy as well. So that's it for this video. Thanks for watching.